Yeah, Sandeep.
Yeah. Okay. So, sorry. So we are talking about this decision tree that we are already having. By the way, sorry for the delay today. I did not anticipate this. So anyway, so yesterday we were talking about this tree. Now, how does this tree tell us how to classify? So given any data, I want to predict either I have either my data is of a class A or class B or class C, any of the classes. So I have classes like this. In this case, I got the first class as whether he is playing golf or he is not playing golf. Now, how I am doing this? I am doing this by splitting the data. Now, what is the splitting the data? So initially, I have all my data as like this. My data is initially like this. One second. Yeah. My data is like this, which is 5 comma 9. What is it saying? It's saying 5 people are not playing golf and 9 people are sorry 5 times I did not play golf and 9 times I played golf. Now I'm splitting my data using some field, some feature or a variable. The variable is called outlook. Now I'm saying anyone having an outlook less than zero point 0.5, I am going to split the data. So this is my condition. Is my outlook less than zero point 0.5? We'll get to the details what it means by outlook less than 0.5, because actually outlook is not like this. Outlook is rainy, sunny, sorry, rainy, overcast, and sunny. So these are the three values that I have. Now outlook less than 0.5 doesn't mean anything unless I convert this outlook rainy or overcast and sunny into some numbers. Let's say I keep rainy as 0, overcast as 1, sunny as 2, or in any other order. If I keep 0, 1, 2, then I can say outlook less than 0.5 means there is only one value. Outlook is rainy. Similarly, when someone says outlook, here again there is another condition saying outlook less than or equal to 1.5. What does it mean? Outlook is rainy or overcast. Two options are present now, because less than 1.5 means either it could be rainy, which is 0, or it could be also overcast, which is 1. Okay, are you clear with this? Okay, so that's how you can define each of these numbers. Similarly, for humidity also same way, whether it is a high humid area or low humid area or moderate area, moderate humid you know weather or whatever it is, you convert those values into some numbers and you give some condition. Now what happened is, when outlook less than 0.5, what does it mean? Outlook is equal to rainy. when outlook equal to rainy, and when that is true, then I have 0, 4 as a value. What does it mean by 0, 4? 0 means that the number of days when you did not play, and 4 means the number of days or number of times that you played. So which means that you have 0 when outlook is rainy. All the time when there is a rain, when the season is when the weather is rainy, then you never chose to play. That's what it means by 0, 4. Similarly, when there is no rain, half of the times you played, half of the times you did not play golf. Now what we are doing is to classify correctly, saying whether you want to play or you will not, you do not want to play. This condition is not enough. The reason is, half of the time when outlook is not rainy, half of the time you want to play and half of the time you don't want to play. So the machine learning algorithm cannot take a proper decision. So what it is doing, it is trying to split again, saying humidity less than or equal to 0.5. Based on that, again it is splitting. When it is splitting based on the humidity less than or equal to 0.5, again you are getting 4 times you want to play, 1 time you don't, 4 times you did not want to play or you did not played, 1 time you played. Now again, I cannot decide based on these two conditions. I cannot say with confidence that you always do not want to play. Again, as I'll split the data, saying outlook less than or equal to 1.5 or not. If outlook is less than or equal to 1.5, then I can say with confidence that all the times I am not playing. Otherwise, again, half of the times I play, half of the times I do not play. So what I'm doing is here, let me go back and give you a good intuition here. What I'm doing essentially is I am trying to split the data every time using some condition. This is my condition. Now when I split, I get some numbers. How many times I have class A, how many times I have class B based on the data. Now after splitting, if I am getting one class as 0 and another class as some number, this is called a pure node. If I do not have one value, one of the class as, all the classes as 0 and one class as non-zero, like this is only one non-zero, one non-zero and all others are zeros. But in this case, there is no non-zero. There is no 0, which means this is an impure node. When you are splitting on some condition and you get an impure node, then you further split it. When you get a pure node, it means that you are not going to split anymore. How you are splitting, we are going to go in detail, but we are just understanding how this is happening in this example. We are going to solve this problem. We are going to understand each and every part of this problem. But the question is, you need to understand whether it is a pure node or not. How do you find a pure node? Pure node is something that has all zeros except one non-zero. In this case, only one non-zero is present. Others are zeros. That's why this is a pure node. In this case, there is no zeros at all. It is an impure node. Are you clear what is an impure node and what is a pure node?
Yes, Sandeep.
So
Yes, Sandeep.
as long as I'm getting a pure node, I'll keep on splitting the data. Okay, here I have 5 comma 9, which means it is an impure node. I split on some variable. Which variable we'll talk about later. For now, I'm randomly taking humidity, for example, in this case. Now, sorry, outlook. First of all, I took outlook. Based on outlook, in this branch, I got a pure node. Now, in this branch, I did not get a pure node. What I did, I tried to uh, I tried to split by humidity. Once I split by humidity, again on true as well as on false, I did not get any pure nodes at all. Because of that, again I here in this branch I split by outlook. In this branch I split it by windy. So when I split it by outlook, on the left side, which is true, you have to always follow this convention. When it is true, you got a pure node here, but when it's a false, again you are getting an impure node. Again, what you do, based on some criteria, you have to again define, again try to split it. How do you split it? In this case, again I am trying to split by windy. Again I am getting two different branches. First branch is pure. Second branch is also pure. So I stopped the splitting for these branches. Now again on windy, if I split, here I got a pure node, and in this case I did not get a pure node. Again I split it by outlook. Once I split by outlook, I get two nodes. Each of these nodes are pure nodes. Okay, are you clear so far? We are going to understand what these numbers mean. Okay, what is this Gini and all these things we are going to understand. But at the basic level, do you understand how we are splitting?
Yes, Sandeep.
Yes, Sandeep.
Okay, 1 second. Yeah. So let's try to write this down in one note. Okay, 1 second. I have to open our notebook on decision trees. I think I did not create. Let me create once. Okay, I'm creating another notebook and I'll open from here. Yeah, I got it. So let's try to understand everything that is happening in that decision tree. I asked you to do the homework. Abid, did you do the homework? I know Vijay did not get a chance.
Uh, no, Sandeep. I will be doing after the class, and I will send you.
Okay. Actually, this is needed for this class, not for the next class. Anyway, so let me do the homework on behalf of you. So let's try to understand what is happening in this tree in detail. I just mentioned on the fly. I did not go through in detail. Now let's try to go into in detail. Okay. Now here we have, let me run all the cells. Yeah, it ran. I'm printing the golf table so that we'll be able to find out appropriate data. Now the question is, how did this, how do we support this decision tree? How do we know that this decision tree is correct or not? Let's try to backtrace it. Let's try to understand each of these values and how this table is created or this graph is created, and we'll understand the basics of tree and all those things. So understand, or let's not create here, let me write it. Understanding the decision tree for golf dataset. Let's try to understand bit by bit. Now first we need to understand how this outlook is less than 0.5. What are these numbers? So for that, let me write it from the data itself. So I printed the golf. Let me print the X also. Now according to this, you can compare and understand what is this rainy. How does rainy, overcast, and sunny are getting encoded? Rainy is 1 according to this. Overcast is 0. Sunny is 2. So let me write that. Outlook encoding. So overcast is 0, rainy is 1, and sunny is 2. That is about the outlook. Sorry, yeah, outlook encoding. Overcast is 0, rainy is 1, and sunny is 2. That's how we encode it. Then what about the temperature? Temperature encoding. Hot, mild, and cool. Hot is given 1, then mild is given 2, and cool is given 0. Okay, so cool is 0, hot is 1, mild is 2. Is that correct? Mild is, yeah, mild is 2, 0 is cool, and hot is 1. That is correct. Now let me write the another encoding as well, which is humidity encoding. How is humidity encoded? Humidity encoding. Again, humidity high is 0, and normal is, where is normal? Yeah, normal is 1 and there is only 2 values. High and normal. High is 1, normal is 0.
High is 0, Sandeep.
Is it right? Or yeah, high is 0. Sorry. Yeah, that's right. That's why I told you to do this, because it will take a lot of time for us to solve in the solve in the class. High is 0 and normal is 1. And finally, windy. What is windy? Windy is either true or false. False is 0. True is 1. Let me write that also. False is 0. True is 1. Okay. False is 0. True is 1. Okay. Now I try to find the actual encoding for each of these values. Now let me go back to the tree and rewrite this tree. How do I rewrite the tree? For example, if I say outlook less than 0.5, I'll say, what is outlook less than 0.5? Anything less than 0.5. Here outlook equal to overcast. So that is the condition here. Instead of writing outlook less than or equal to 0.5, I'll rewrite it as outlook equal to overcast. So outlook equal to overcast. So if outlook equal to overcast, initially actually what are the number of so number of people, number of times we played golf versus number of times we did not play golf. How do we find out? We have to count number of S's and number of no's. So how many no's are there? 1, 2, 3, 4, 5. 5 no's are there. Okay. Before splitting, there are 5 no's. No, which one you should count? You should always count the final class that I want to predict. I want to predict whether I want to play golf or not. Now, based on this, I have to count how many different classes are there, and what is the number of what are the counts for each of them. So there are 1, 2, 3, 4, and 5 no's, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 yeses. So before splitting on overcast, I have 5 times I did not play golf and 9 times I played golf. So that's why I create a node using 5, 9. That's what is the first node. Okay. Now, if I split on overcast outlook equal to overcast, what happens? So to do that, I am using Python itself, because that is the easiest way I can find out the counts. So even the first count, the 5, 9, I can easily get using golf dot value. I'm sorry, golf of play golf. On play golf, I have to find out value counts. How do we do that? Value underscore counts. If I do that, 9, 5, I get it. Now what I need to do is, I need to do some selection. What is that selection? Outlook equal to overcast, I have to select. How do I do that? Golf of outlook equal, golf of, again golf of outlook equal to overcast. If I do this, I'll get only overcast values. Now on this, if I do value underscore counts, sorry. On this, I have to select only play golf dot value counts, value underscore counts. Then I'll get the counts. All are SS. So how do I write that? If this is true, if outlook equal to overcast, this is true. If that condition is true, then I would say 0 comma 4. Is it right? Yeah, 4. All 4 are SS. There is no value that is saying no. Now what about if it is false? False. How do I know that? If I do outlook not equal to overcast, I'll be able to get all the outlooks where all the days where outlook is not overcast. And then I did a value counts. I got 5 comma 5. I can simply write 5 comma 5 here. What I'm counting? Always this count is always on the classes, which is the play golf or not. Yes or no. That I am going to count. Now when outlook is not equal to overcast, I have to find another variable on which I have to split the data again. Now the algorithm found that humidity less than 0.5 is the better variable to split on. Now how did it find the humidity equal to 0.5 is not something that we are going to understand at this moment. We are going to understand a little late. But assume that the algorithm or the computer already found that humidity less than 0.5 is correct. Now what is humidity less than or equal to 0.5? When humidity is less than 0.5, it means that the humidity is high. So instead of writing humidity less than 0.5, let me write it as humidity equal to high. When there is a high humid environment, as well as when the outlook is, if you see this tree, outlook is already overcast, as well as humidity is also high. You should read the table like this. You should read the graph like this. The outlook is overcast, as well as, sorry, outlook is not overcast because it is a false. Outlook is not overcast, as well as humidity is high. In that case, when humidity is high as well as outlook is not overcast, you will go into this direction, which is true. When outlook is not when outlook is not overcast, as well as when there is no high humidity, then you will go into this branch. How do you calculate this again? Again, using Python, we can easily calculate. That is the easiest way. And yeah, this one. Golf of, let me try to give humidity equal to 0, or sorry, it is, what is it, high humidity, high. Maybe this is not this, and 1 second. Okay. Oh, this is a little difficult to do in pandas. Let me do one more thing. Golf outlook, I'm just simplifying it, not overcast. When outlook is not overcast, I already selected some variable, some data. On this data, I'm going to select saying golf of humidity equal to high. If I do this, I'll get only the set of variables where we get only humid data. This is the only high humid data, as well as as well as outlook is not overcast. Both the conditions are satisfied at once. Now, if I select play golf on this dot value counts, then I'll be getting 4, 1. 4 is the no, 1 is yes. Now, what I'm getting is when outlook is not overcast, as well as there is a high humidity, I'm getting 4, 1. Let me remove this box. 4, 1. When there is a high humidity as well as outlook is not overcast. What about this side? This side it will be, we have to say humidity not equal to high. Then again we are getting 1, 4. The reason it is 1, 4 is always start with no. The number of no's is 1, number of s's is 4. So it will be 1, 4. Are you clear so far?
Yes, Sandeep.
Vijay, are you also clear?
Yes, Sandeep.
Any questions? It is very easy, but yeah, if you still have any questions, you can ask me. Okay, so this is how we keep on continuing. I'm not continuing until the end. I think you got a fair idea how this table is built. This table is this graph is built like this. We start with the root node where we don't have any partitions. Just count overall how many yes, how many times we played golf, as well as how many times we did not play golf. Play golf dot value counts. So overall how many times we played golf, overall how many times we did not play golf, we'll be giving the counts. The next level what we do is we try to select one variable and try to give some condition on that variable. How this condition is formed is not something that you are taught as of now, but we'll learn that later. So assuming that this condition is already given, what you try to do is you splitted the data based on this condition, and again you try to do the counts on the classes. If you are having a pure node, it means that you are able to classify properly with this condition. If you are not getting a pure node, if you are getting an impure node, then you are not classifying it properly. So you have to split it again. How many times you have to split? You have to split as long as you are getting, until you have to split, you keep on splitting until you get all pure nodes. Now, the question is, how do you split? That is the first question we need to answer. But before all these things, we need to understand a few terminology. In this kind of a tree, this is called a tree actually. This is a tree. This entire thing is a tree, and we are deciding the classes based on the tree. So we call it as a decision tree. What is a decision tree? Decision tree is nothing but if you want to decide whether you want to do some x or you want to do some y. In this case, the X is you want to play golf, Y is you don't want to play golf. So you want to decide whether you want to do whether you want to play golf or whether you don't want to play golf. To decide that, what we are doing is we are using this tree. What this tree is going to do is it is going to split the data based on some variables, some values on the variables, and it is going to give some counts. Now, any node, any tree will start with a root node, and this root node is having some children. So let me call this as child of node. Let me call this node as 1, 2, 3, 4, 5. We'll still have some more things, but we did not draw them. So this node is a child of node 1. Node 1 is this one. This is also another child of node 1. Child of node 1. So what we have is in this tree, the tree starts from the root node, then it will have some children. Again, each of those children may have few more children, but some nodes will not have any children anymore. This is called a leaf node. Leaf node means doesn't have children. A leaf node is something that doesn't have any children. So compare this with the normal trees that you see regularly in nature. So every tree will have some root node and it will have some branches like this. Each branch will have some more sub branches. Finally, there will be a leaf. The leaf is where you will not have any more branches. That's why it is called leaf. Except that in real world, the trees are not inverted like this. Root will not be at top. The tree will start at the root, but root will be at the bottommost layer. It is just an inverted tree. Then whatever tree you see in nature versus whatever tree, decision tree that we will try to use, it is just an inverted nature. Are you clear, Vijay? I think you don't have a background of computer science. That's why I'm just describing a little about the tree.
Yeah, it makes sense.
Okay. Yeah. Any questions so far?
No, nothing so far.
Okay.
No, I'm good, Sandeep.
It is easy, right? Are you feeling it easy or difficult? The decision tree.
I mean, it's easy. Like, I did decision trees before also. I don't know where, but it's basically logically you go through it.
Yes. Yeah. Okay. Sure. Okay, then we'll take a break. Obviously, it is a break time. So we'll catch up again at 7:30. We'll continue understanding decision trees. Okay. Now it's your duty to complete this. I did not complete this tree. You have to complete it. Use Python or whatever you want to use and try to find out the splits and write down the tree. Okay. So we'll catch up again at 7:30. Is everyone back?
Yeah, I'm back, Sandeep.
Yeah, I'm also there.
Okay. So let's try to understand decision trees in detail, in much more detail actually. Um, One second. Let me delete all these comments. I have done this last time. Now if I remove it, so I'll be able to. I don't know, so many are there. Okay, that's okay then. We'll start with the discussion. We'll delete it as and when we see. Okay. So we will try to understand decision trees from this PPT again, the way we understood earlier. Again, this is from the same person, the PPT. I don't know if there is a full screen mode, it is not there. Okay. Hopefully you're able to see it properly. Is the size of the window is okay? I do not have the full screen mode here somehow. Is the size of the window is clear? Or do you need a bigger screen?
It
Yeah,
seems
it's clear, Sandeep.
Okay, it is clear. Okay. Okay. Let's try to understand this decision trees from this PPT. Now the problem is this one, predicting loan defaults. So many people will go to bank, they'll take a loan, but only few people will return. Will repay the loan, and the remaining people will default, which means they will not repay the loan at all. Now we want to predict, as a bank, we want to know prior to giving the loan whether he will default or not, based on the behavior, based on his customer profile, his behavior, many traits. We want to understand whether he will default in future before giving the loan itself, so that I can avoid many of the potential defaults. So that way I'll be able to help the bank to gain more traction in the loan recovery. So to understand that, we are going to take that example and understand how to create the decision tree. We already understood many of the aspects of decision tree, so this PPT should be very easy for you to understand. So what makes a loan risky? So you want to buy a house. What makes a loan risky? Anyone? It may not be just this. You can just think about something and give me an answer.
bad credit history.
Yeah, the credit history is one very major, very big thing. Yeah. Anything else?
Very low income.
Very low income. Yeah, that is also there. So if he is, if he is taking a very low, very high loan when his income is very low, that is also very risky. What I mean is, income as well as the loan that you are going to take, both together are going to be very risky. Anything else?
Personal information.
No, don't read it from here. What is personal information? How would personal information make loan risky? You think about that and tell. Don't read from here and just tell.
I can say low income is only one option, which I guess.
Mhm. So if I say I'll take a loan of $1 million, but I'm going to invest that in stock market versus I'm going to invest it in a house. Those two are two different aspects. If I invest in stock market, my risk is high. If I invest the same thing in real estate, maybe the risk is kind of low, comparatively low. It may not be very lowest, but it is kind of low. Is that correct? So where do I want to invest? That loan amount is also very important. It is not written here, but I'm just telling you, because for example, if I take a loan of 1 million and if I put it in buying a car versus if I put it in a, I mean if I use that money for buying a house, those two are completely two different loan applications. One is for luxury, another is for investing and improving your life. So when you're trying to use the loan amount for buying a car, tomorrow the car will be the price of the car will be only reduced. So if I buy a car today for $1 million, the next year it will be only $80,000. Yes or no? So where do I want to invest the money? If I invest the money on a right place, then the risk is comparatively lesser compared to if I invest in stock market or Bitcoin or cryptocurrency. I bought Bitcoin for like let's say uh, $8,000, and tomorrow it became only $1,000. The risk is more. Hope you know about cryptocurrency, but I invested in personally as well, and I lost a lot of money. So that is a risky item. So risk is also based on where I want to invest. Where I want to invest. Is it clear? You have to find out all these places where I want to invest and find out which places are risky, which places are not so risky. If I want to do farming and I want to take a loan, it is comparatively less riskier than if I want to do a stock trading or stock brokering and I want to invest money there, because you never know when your money will be zero in stocks. So all these things will make risky, but here in this PPT there are only few items that are identified. One is credit, which is your credit history, your income details, the term of your loan. Again, if I ask for a $1 million loan and I kept the term as only 5 years, there is a high chance that I'll miss it because my salary is only, let's say, 80K. I'll never get $1 million in 5 years. Even if you multiply $80,000 per year into 5 years, I'll be only getting some 400K. I'll never be earning $1 million in 5 years. So it is a risky loan. So all these things correspond to the risk, whether it is a risky loan or safe loan. Okay. Now, that's what he is explaining. So credit history, for credit history, whether he repaid earlier or not is very important. If he already did not repay earlier, it is obvious that he will not repay now also. He'll default. So that is the reason why we will take the credit history. So based on whether it is excellent, fair, or good, these are the options you might have. Based on these things, you'll be able to identify whether he will repay the loan or not, or whether he will go on a default. Again, the same thing on income. Based on your income, actually he did not explain, he explained only about income, but income should always be correlated with the loan amount. It doesn't matter whether his income is very less or not, but you have to correlate with the loan amount. For example, if your income is 80k, like the way he gave here, 80k per year, but the loan amount is only 60k, it is very safe loan, you can still give it. But let's say if his income is 80k, but I am asking for 10 million, so it will take at least uh, at least 20 years for him to earn 10 million. So it might be very risky for him, for the bank to give $10 million as loan when his income is only 80k. So you have to always correlate the loan amount that you are proposing with the income that you have. Without this correlation, income by itself may not be a good measure, but in this case he has given like that. So we'll follow the pattern that is given in the PPT. Again, the same about the loan terms as well. For example, again, $1 million, if I say that I'll repay in 3 years versus 30 years, there is a lot of difference. Again, two less loan term is also very risky, as well as if he's saying I'll repay in 30 years, maybe again it is also risky. It should be moderate enough compare when you see the loan amount. You have to always correlate with the loan amount. Based on that, you have to find out a better number. Again, personal information, there could be many reasons. If he is married, then maybe at least even if that person is not able to repay the loan, maybe you can ask the person's spouse can repay the loan. So these are some alternative arrangements that you can keep in your loan agreement. If that person is not able to repay, you should ask that person's spouse to repay. So home loan for a married couple is going to be much more easier, because the spouse can repay at least. If that person, if assuming that both the couple the couple is working, it's not one person that is working, based on that assumption. As well as there could be another reason about the personal information. Let's say the person is not a citizen. If he is not a citizen, he can anyway go back to his home country and and he can choose not to repay the loan. That is another reason why that person may default, because he is not a citizen of that country. So all these things, even the age, if that person again is let's say having an age of, let's say, 70 or something, 75, then there may be a chance that he may not repay the loan because of his health issues or anything like that. So all these things are very important in determining whether he defaults the loan or not. Are you clear so far? How would all these things add up?
Yes, Sandeep.
Now what we need to write some intelligent loan application system where we get the loan application, we process it automatically, and then we categorize the loan application. We'll put the loan application, let's say these are the different buckets. We'll put the loan application in one of the bucket. You get a loan application. First loan application, maybe you put it here. Second loan application, you put it here. Third loan application, you put it here. You automatically categorize these loan applications so that there is no manual effort at all. You get a loan application, immediately you decide based on some logic, you decide whether you want to keep in this bucket, or you want to keep in this bucket, or you want to keep in this bucket. One of the buckets you want to keep. So to do that, you want an intelligent system. Okay, is it clear so far? I think I did not cover anything, but still, if you have any questions, definitely. Let me remove this. This is not needed. Okay. Now, in machine learning terminology, what you need to give is this loan application. You have to give it to some classifier model, some machine learning model. You have to give. That model will automatically categorize the data into either safe loan or risky loan. In this case, we are saying safe loan as +1, risky loan as -1. But you can use any terminology. You can say safe loan as 0, safe loan as 1, and risky loan as 0. You can use any kind of a notation. In this case, he is using +1 and -1. Normally, we use 0 and 1, or 1 and 0, whatever it is. Okay. You can use any terminal, any notation. That is up to you. Now, decision trees is always building a tree like this. You keep on asking for some questions. So when you start, the first question here is, what is his credit history? If it is excellent, immediately say it is safe. If it is fair, then you have another condition to ask for. If it is poor, again you will have some more conditions. So if you follow through this decision tree, finally you will get into some leaf node, and the leaf node is going to tell you about the decision that the decision tree is going to give. And this entire tree is nothing but your classifier. So we want to build this kind of a tree. Now the question is, how do we build? I already gave you the intuition about the decision tree. So if the credit history is fair, as well as the loan term is 3 years, then I decide that the loan is very risky to give. At the same time, if the credit history is fair and you have 5 years of loan term, you say it is safe. All these kind of decisions are just done just by following this tree. The only problem is, how do you create this tree yourself? So again, he is giving some more example. When credit history is poor, which is this direction, and income is high, which is this direction, and learn term is 5 years, then it is safe. But if his credit history is poor as well as income is high, credit history is poor, income is high, and loan term is also 3 years, then there is some fraud in the application. So based on all these conditions, you have to find out. So you can see here clearly, the credit history is poor and income is high. There could be, I don't know if you, Vijay, if you know about the recent happenings in India. I do not know really about the US, but in India, when income is high and credit history is poor, it is very difficult to get a loan, because when the income is high and credit history is poor, he is of a some kind of a high class person, and he is more likely to fly off from India. So when credit history is high, sorry, credit history is poor, as well as he is of a high income group, he is more likely to default than anyone else. So it is very, very risky.
Yeah, that's the same here also.
So
You need
yeah,
credit history.
you need a credit history. Even if the income is high, the moment credit history is low, it is very, very risky. So that's what this tree is also saying, except that it is saying a little different. When the term is very low, then you call it as risky. When the term is a little high, then he has enough time to repay. That's what this tree is saying. But at least in reality, the moment you have a credit history low and income is high, when the income is also kind of moderate, I would not say it is. When the income is moderate and credit history is poor, I would not say he is a likely defaulter, because he will not fly off from the country. At least when the income is also high, he will definitely fly off. That is what is happening, at least in the recent past. So that is how we take the decisions using decision tree. But taking decisions is very easy once you construct the tree. The question is, how do you construct the tree? That is a more important aspect. This slide is just saying, it is just saying to replace this classifier model using the tree. That's what it is saying, nothing else. Now, how do you build the decision tree? That is a more important question. You have some observations. So, for example, first person is having excellent credit history, 3 years of loan term, high income. He is of high income group, and I can predict him as his past history is saying that after giving a loan, he safely repaid. He repaid. It's not a future one. It is a past data set. Based on this data, he already repaid his loan. Again, another person, he is having a fair credit history. It's not an excellent one, though it's not a poor as well. And he is asking for a 5-year loan term, and his income is very low. And now the problem is, his income is low and his credit history is also not so good. It's not too much good, at least. So based on this, our past history is saying he did not repay the loan, so we marked it as risky. So likewise, we have all this data. Now based on this data, we have to build a tree, just like the way we build the tree for golf data set. Now we want to build a tree, similar tree. How do we build a tree? I think this is the right time to stop the class, because we'll anyway not be able to complete the topic on how do we build a tree. So let's close the session for now today. Do you have any questions so far?
No
I'm
question.
good until now, Sandeep. I'm clear.
Okay, we'll close the session for today. So just try to complete this tree yourself and send it through the mail for me before the next class.
Okay.
So
Thank
if
you.
the only problem is, if you do not do it, Tomorrow, if you do not understand, don't ask me questions. It is your problem. Okay?
Okay.
Sure, Sandeep.
No, I'm just kidding. But please do the homework. Uh, it's not that you do not have to ask questions, but the problem is I will be having tough time answering your questions if you do not do the homework. Okay?
Okay, Sandeep. Thank you.
Yeah, sure then. Any questions? Not just in decision trees, anything else? Do you have any problems with my way of teaching or anything else?
No problem.
Okay. Any problems with me, Abid?
No, Sandeep.
Okay. Hope you're getting everything clearly. I do not want to proceed unless all of you agree with whatever we discussed in the class. That's why I am going very slow. It may take time. We started in January 22nd. Is it right?
Yeah.
It is already 4 months. I said 3 months, and we are still not done. So I'm okay because if it is late, more than you, I am the more sufferer. I have to teach more. Uh, I cannot start another batch. I'm losing money. All of the problems. So I'm the more sufferer than you if I teach more. But I'm okay. I do not worry about if it is going beyond 6 months. Also, I'm fine. The question is, are you able to learn or not? So that's what I'm interested in. So hopefully, also don't mind about class getting extended. I'm sorry for that, but the problem happened with Python. The moment Python is in the equation, everything got changed. But I hope at least you will be able to grasp the concepts and able to do everything in Python. At least if that is there, we are successful in this class. Okay.
Yeah, no problem, Sandeep.
Okay. Sure then. Okay. We'll catch up on Monday then. Thank you and bye.